Good morning everybody. Now today we are here to start our new course on neural networks, which is common for CSE and IT. So we'll be seeing what are we going to cover in this particular subject of neural networks. So Unit 1 deals with three parts. First is introduction to deep learning, second is regression, and third is classification, as you can see. So within each subheadings you will see a lot of, within each subpart you will see a lot of subtopics that we are going to cover. So if I pick up for today introduction to deep learning, in that we are going to see about fundamentals of neural networks and deep learning applications and deep learning framework. So today's topic we are going to pick up about fundamentals of neural networks and deep learning. So before I actually dive into the fundamentals of neural networks and deep learning, let us have a look of what it is. We all know deep learning is a subset of AI. So AI is artificial intelligence, and what are the stages of it? We are going to just have a gist about it. So artificial intelligence is a technology that allows the machine to acquire intelligence and inferential mechanisms just like humans. So as we are aware, we want to impart human intelligence to the machine in other way. So that is what is artificial intelligence. So in the first stage of artificial intelligence, few intelligent systems were developed which summarized and generalized some logical rules and then implemented them in the form of computer programs. So this was the most initial stage of artificial intelligence or AI era that we call. Now the second stage of AI actually deals with what we call as machine learning. So the second stage of AI was born in around the era of 1980s, and a research discipline that allowed the machines to automatically learn the rules from the data available. This was called as machine learning, and it was a very popular subject of AI in the year 1980s and the era of 1980s. Now third revival of AI that we call is what actually is our subject, that is deep learning. So it was since 2012 that the applications of deep neural network technology have made its major breakthrough with the fields like computer vision, natural language processing, NLP, and robotics. So this is the era that we are talking on. This is our subject that we are working with, that is third revival of AI, which is deep learning. Now we are going to talk on advent of neural networks and deep learning. So with this topic we would see how actually neural networks evolved, how deep learning evolved, and what is little bit history of it that we are going to see. So early neural networks, if I talk about when neural networks were introduced, I can broadly classify actually a neural network into two categories. One is a shallow neural network, another is a deep neural network. Now you can assess it with the name itself, a shallow, a little bit lower in dimension, and deep neural network, which would be a little heavier network. So the earlier inventions, they were all shallow neural network. In 2006, Geoffrey Hinton proposed the concept of deep learning, while the significance of deep learning was felt in the year 2012 with the advent of LXNet, which is an 8-layer deep neural network, and this particular network LXNet was released and it achieved huge performance in image recognition competition. So this was the first time we could taste the success of deep learning actually. The algorithms implemented using such deep neural networks are referred as deep learning models. Right now, do not worry on shallow neural networks, deep neural networks. We will cover everything in detail. Now, with the advent of this neural network, the comparison of a deep learning algorithms with some other algorithms, I can explain you with the help of this following diagram. So let's have a look at the diagram. So as you can focus onto this diagram, I can explain you that there are 4 different types of algorithms that we can see over there. The first one being rule-based system. So if you look at the rule-based system, you have handcrafted rules and then output logic over there. That means the rule-based system, it usually writes explicit logic which is generally designed for specific task and it is not suitable for any other task. Alright. Now the second one that we are going to discuss is about traditional machine learning algorithm, and I hope you are all aware of all machine learning algorithms so far. Now these machine learning algorithms, they artificially design feature detection methods and with certain generality, and such example for such feature detection methods would be sift and hog features. Okay, and the performance of these particular algorithm depends on how those features have been designed. Okay. Then the next algorithm that turned up was neural network algorithm. So emergence of neural network have made it possible for the computers to design the features that we were discussing with machine learning, to design those features automatically through the neural networks without any human intervention. Now this all started in neural network. So neural network, you could see the first neural network that you are able to see is a shallow neural network. So obviously it had got its own disadvantage, it won't be working on high level of data. But then with increase in the research, we are now into deep learning era, which overcame all the limitations of shallow neural network like limited feature extraction capability. Okay. So when we go on to deep neural networks, which involve deep learning algorithm, they are capable of extracting high level abstract features, and they do have better performance when compared to other algorithms. So this was the advent of neural network and its algorithm, deep learning and its algorithm. Sorry. Now that you have seen how deep learning algorithms and deep neural networks have evolved, we would now like to see the next part, which is what is the relation between AI, deep learning and machine learning. So for this, you just focus on to this particular diagram. Now you can see onto this particular diagram, and you can say that AI is the superset. This is symbolic AI as an example that I have kept over there. Symbolic AI is an algorithm of AI. So this is the superset. Inside that there is a subset of machine learning. So machine learning algorithms, few examples like decision trees, kernel methods, etc. And that inside machine learning there is another subset called neural networks. The first evolvement was shallow neural network, and then lastly the final subset that we call it as a deep learning. Now from here onwards, these deep neural networks will now be referred as deep learning itself. Okay, so please do not get confused on that. So here you can see the overall relationship between AI, ML and deep learning. So I can say that deep learning is a subset of machine learning, which in turn is a subset of AI. So AI is the superset, and then deep learning is the subset of AI and machine learning. That's the relationship between AI, deep learning and machine learning. Now let's talk a little bit on history of neural network, because here you will be really understanding about what exactly is a shallow neural network. You will see about the development timeline of the shallow neural network, and then follow it up with how deep neural network evolved and its development timeline. A few terminologies will be new for you regarding the names of the networks, but then we are supposed to cover everything of them eventually in the upcoming videos that you will be seeing. So right now you just concentrate on how the history evolved. Alright. So as I begin with the first one, which is shallow neural network, we actually divide the entire development of neural network, as I discussed, into shallow neural networks and deep neural network. So shallow neural network, if I am talking on, the advent began in the year 1943, where a psychologist called Warren McCulloch and a logician called Walter Pitts, they both proposed an MP neuron model with their initials, of course, McCulloch and Pitt. MP neuron model was proposed. Now MP neuron model actually looks like this. Now you can just have a look here. This is an MP neuron model that you could see over here. So what do you see over here is these three, I have kept three, there can be more than three inputs which can take up logic 0 or logic 1, and then you have in between a logical mathematical function which is divided into two halves that you can see over there, which is G and which is H, and then finally it would give you an output of 0 and 1. Okay, so now that you here the problem with this McCulloch-Spitz model was that there was no learning ability. Learning ability means here how this model works was, the mathematical model is f of x is equal to h of g of x. That means this particular output f of x, x is nothing but the input that you give, the output is nothing but an f of x. This f of x is nothing but an application of these two inbuilt logical functions over there. First you would apply a g of x, to that you would apply a h of x. Okay. Now as we begin, we will see what is it g of x and what is it h of x. See, g of x, if I talk about a McCulloch-Spitz model, then it tells you that if g of x is greater than or equal to 0, then the output is 1. If g of x is less than 0, then output is 0. Okay. So what is this g of x? G of x is nothing but sum of all these inputs. So these input values could actually be 0 or 1. That means if any of this input is 1, then adding all of these things you will get a g of x as 1. If g of x is 1, then definitely the output of that part is going to be 1. Any one of the inputs should be 1, that means. So this was the first of its kind of a model where you mathematically you are putting it like there are all inputs, you are just taking, summating them and giving it to a mathematical model, and then this particular part of H is going to be an activation function which is going to decide the final output that is going to come. So g of x will give you the sum of the inputs and h of x is going to decide what is g of x. G of x, if it is less than 0, then it will give the output y as 0. If it is greater than 0, then it would make the output as 1. So you could see that it is just giving you summation, result, and then an output as a 0 or a 1. There was no proper learning inside this particular model, although this was a stepping stone into shallow neural network. Alright, the limitation was it had no learning ability. Now, here, the next invention came in the year 1958 where American psychologist Frank Rosenblatt proposed perceptron. So perceptron came into picture. Perceptron had learning ability. Now what do you understand by learning ability? Learning means you have to identify what mistake have you done and you have to learn from it. So that was not possible with a McCulloch-Spitz model, but a little bit was possible with the perceptron model. So this is how a perceptron model looks like, and you could very clearly see this G, like when I talk about here, if I go back to the slide, you can see there's this mathematical function divided into two parts, G and H. So when I go now, here I can see this is G and this is the H part that we were discussing with McCulloch-Spitz model. Now learning is introduced into this particular model where you can see this is the feedback function, okay, the error that you are getting calculating here. So if I talk now, what am I going to talk? One more thing, learning, when I say I have also introduced weights for these particular inputs. That means I am trying to give some priority to my inputs. I am trying to add weights to my inputs as well in place of normal inputs. Alright, so when I look into this, I still have inputs, but unlike MP model, I have here weights associated with my input. I am going to give a summation of all these weighted inputs. Now my terminology is changed, weighted inputs, and then I pass it on to the activation function now. But then of course it is going to give me an output, but then post that I would try to evaluate what went wrong in my realization, and based on that we will adjust our weights of the inputs so that we get output more and more correctly. More on this we are going to cover, we have it in our subsequent chapters, but for now you understand what is the difference between MP model and a perceptron model. So we have weighted inputs, then we try to learn out of the model and update the weights of our input. So the learning was possible in perceptron, but there was, yes, a problem with this perceptron model as well. This model could solve only linear problems. It could not solve, this problem could solve only limited number of problems, but it could not solve some linearly inseparable problems like an XOR problem. So if you wanted to implement a nonlinear model out of a perceptron, then it was a task. Single perceptron was not able to do that. So later on some research were made, and now we are into dealing with huge models of neural network. That all we will see in our subsequent chapters how it went. Right now we are into the development timeline, so I am not putting much into detail here. You try to understand the inventions that took place. So the very first thing that we saw was 1943 MP model, now 1958 a perceptron model. And then came the advent of a shallow neural network, as I told you, with perceptron. So the shallow neural network, as you can see, consists of three basic layers: input layer, output layer and the middle layer. This middle layer is nothing but what we call as a hidden layer. So this is a very simple structure of a neural network. We call it as a shallow neural network. Now this is about the development timeline of a shallow neural network. I would like you to please focus on to the diagram, and then I shall give you now the details of the shallow neural network timeline. So what we are able to see over here is, as I just discussed, in 1943 we got our shallow neural network introduced in the form of McCulloch-Spitz model. 1943 it initiated everything, which was neuron model, and then in 1950 we got Turing's test completed on it, and then 1958 we got Frank Rosenblatt proposing the first neuron model, which we call it as a perceptron model. And then we got in 1969, that was the era which brought us the main flaw of the linear models like perceptron, which could not handle simple linear inseparable problems like an XOR problem. So this was a very tough period of perceptron related research on neural network, 1969. Basically from the period of 1969 to 1982 is what we call it as a first winter of artificial intelligence. It was a very tough period of AI, but still there were significant studies that took place over there, where in 1974 the study of backpropagation algorithm took place. Backpropagation is the core foundation of all the modern deep learning algorithms. Okay, and then in as I told you, the attention was not much provided to the backpropagation algorithm. Still the research work had been carried out wonderfully at that time. Now during the second wave of AI renaissance that we call it, it started from 1982 till 1995. Now this was the period where convolution neural networks, recurrent neural networks, backpropagation algorithms, they all were developed. Now 1986 was an era where Jeffrey Hinton and others, they applied actually the backpropagation algorithm to multi-layer perceptrons. Okay, perceptrons with multiple layers. So you can see over there 1986 is an era which is of very much significance. We got multi-layer perceptron, RNN, restricted Boltzmann coming into picture. And then 1997 we got LSTM. Before that 1990 ELINet, which is a part of CNN, and finally in 2006 what you got is a deep belief network that we say. Now this was the development timeline of shallow neural network, and from 2006 now onwards we were now into the stepping stone for deep neural network. So if I talk about a gist on deep neural network, it's a very simple neural network The only thing is you have got multiple number of hidden layers. Okay, we will discuss very soon what are the differences in detail about shallow and deep neural network, but for now you can understand this is a basic neural network, deep neural network with inputs, outputs and multiple hidden layers. That's how a deep neural network looks like, with all interconnections amongst the neurons. Now, if I talk about the development stage of deep neural network, we divide the development of neural network, as I said, with shallow and deep neural network. So, I am now talking from 2006 onwards, where I come across deep belief neural network, and then 2009 with ImageNet, it is one of a type of CNN, 2012 CNN AlexNet, 2014 VGGNet, GoogleNet, again a part of CNN. 2014 onwards, we are now into a little bit of more in-depth neural networks like GANs, DQN, batch normalization got introduced in 2015. TensorFlow, which is a very powerful framework for deep learning, got introduced in 2015, and then AlphaGos, then BERT, and OpenAI, which was a revolution in 2019. So, there is no looking back to deep neural network right now. So, it just started with 2006 and then it will be continued so on. So, I would stop this here. In the next class, we will see with how shallow and deep neural network, they differ with each other in depth, and various other characteristics of deep learning. Thank you.